We're going to look at now at a Tach and what makes it work. There are really just three components. It has a little pickup, and the pickup is really just a cable. It's got a little sensor on the end, and that's right near the crankshaft down at the bottom. Let's point out where that is. It's on the driver's side, right underneath the vacuum pump, right down in there, and it's a little pickup that senses the rotation of that crankshaft. So that digital signal is fed through a cable up to a little unit right up here, and this is the Tach Sending Unit, and that's what we're going to change tonight. The one on this car is bad. The symptoms are that you get an intermittent Tach signal. This little unit converts the pulses that picked up off the engine into an analog signal, and that analog signal is fed to the tachometer unit, which is a little amplifier. And so that little sweep unit that runs the tach back and forth that's inside the car is being fed by this. This is most frequently the thing that fails, and what we're going to do is change that. We'll show you how simple it is. It's very rare that the actual Tach electronic circuitry in the Tach fails. All we're going to need to change this sending unit is just a Phillips screwdriver. If you notice, there are two Phillips screws right here. We need to change those because we don't want to cut that little thing that keeps it there. So if we take these Phillips screws, and actually we could have pulled that thing off, unscrew it, and actually unplug it first. The only reason we had to take those Phillips screws out is to get this little thing out of there. You can see that it's this little, just plugs up underneath there, and that's the unit that's bad, and we can look at that. Inside there's an electronic circuit, and that's the sending unit. That's typically the thing that makes it work intermittently. So we have a new one here, and all we do is plug it back into where that was and then screw it back in there. You really didn't need to take both screws all the way out. Hopefully our Tach will work. All we do is plug that back in. Looks like a diagnostic plug to check the engine where you hook an instrument, but it's not. It's the sending unit for the Tach. Done. Now, what we can do with these Tach sending units that we found out is frequently they fail because they've got cold solder joints. But in order to get to that circuit, which is inside there, we need to get that out of there. It doesn't come out this way. It's held by little tabs. So what we've determined is a way to get it apart is to saw the end of it off. So if we make sure that the circuit part is out here, we're just going to put a little mark on it so we know. You know exactly how it goes back together, because we're going to have to put it back together. You're going to put it in a vise and just take a hacksaw and saw the end of it off. So, oops, need that out. So if we just put it in a vise, we've got it marked, and we're just going to take a hacksaw and just saw about right there. So here we go. We got it marked, and now that I've hacksawed it, it just comes apart. And if I set the little top piece that I hacksawed away aside, you can see that the circuit that we want will come right out of there. And you can see it's siliconed. It's protected, and that's what we need to pick off of there. So we're going to pick all that silicone off of there. It's kind of a little painstaking process, but it's worth it. And once we get down to the solder joints, then we're just going to solder those.
Hello. Jim showed you how to remove the Tach sending unit from the engine compartment. He also showed you how to cut the top off the cap. The reason that we do that is so we can extract the inside electronics module. You'll notice that Mercedes uses a silicon sealant to seal the top of this to cover the circuit board, and also inside there's silicon sealant. That's to cut down on the vibration, but inevitably over time, 18, 19 years, there's bound to be some solder joints in there that work themselves loose and become what we call cold solder joints. We're going to show you how to repair those. The first thing we need to do is you'll notice that there's some little retaining clips or tangs a third of the way around this module. This is the reason we had to cut the cap off, because these modules won't allow us to extract it from the cap. We cut the cap off, we back this out, we're going to re-glue the cap back on, and Jim will show you how to do that later. And then we repair this, and then we can slide this in and out at any time that we want. In the future, if we should have another problem, we can address it then. So the first thing I do is I take a little Swiss Army knife and I insert it behind the little tangs and I break them off. It doesn't damage them, but then now it will allow you to reinsert it, like I said, and remove it at any time in the future. So now that I've removed those, that's the first thing you have to do. The second thing you have to do is you have to remove this silicone adhesive or sealant. There's no easy way to do that, and if anybody finds an easy way, please let us know. The only way that I've found is to just chip away at it with a pocket knife. You'll notice that there's a circuit board right here, and what we want to do is we want to take this silicone adhesive and the sealant, and we just want to peel it off, exposing the circuit board. As you can see, when we first start off, we can take this off in big chunks, and it becomes very easy to remove it in large chunks. As the large chunks are removed and we get closer to the circuit board, it's going to be a little bit more difficult to remove the little fine pieces that are close to the circuit board. Okay, you can see this pile of silicone sealant that I've removed. I find it easiest to start and work my way around the circumference of the module, and then continue to remove the big chunks across the center. Now that we're here, it just takes a lot of tedious little picking in order to clear it off. You can do this while you're watching a football game, listening to music, visiting with the family. It's just a little, almost like crocheting for the auto mechanic. So continue to do this until the circuit board is clear. I'm going to show you a circuit board that has been cleaned and soldered. But next we're going to show you a circuit board that has not been soldered and some of the cold solder joints on it. Tach sending unit with you can see that the silicone has been scraped off of here. And if you look real close right here, you'll notice that around the outside of that soldering joint, it's come loose. That's a cold solder joint. This unit right here is not soldered, but you notice it comes through a hole where it's not supposed to be soldered. This one right here is supposed to be soldered. And if we make our way across, you'll see that there's several others. Down here there's one, over here there's one. I will rotate the unit around until I can show you a couple more here. Right here in a row, there's three of them. Right here is a cold solder. This one right here appears to be fine. That one is a cold solder. You can see the line around it, and certainly that is a cold solder. You can see that right around the top here, it's come loose. So the vibration over time has caused these connections to come loose, and therefore they're intermittent. What we're going to do is we're going to apply a soldering iron, and we'll make our way from left to right all the way across the circuit board, and we'll resolder these connectors. And in so doing, we'll also add a little bit of solder to each one of them, and thereby beefing them up so that the time at which this will fail again down the road will be lengthened. This is about a 19-year-old module, so we know that if we go in and resolder it and add more solder to it, that we're going to get about another 10 to 15 years out of it, if not even longer than 19. So let's go ahead and show you that. Alright, what you see here is the top of the Tachometer Sending Unit. And I have a soldering station with a very fine tip, as you can see, and I have some very fine electronic solder. Now with solder, when you're soldering, solder flows to the source, to the heat source. So what we want to do is we want to apply our soldering iron to the opposite side of the little volcano that we talked about earlier, and then apply the solder to it. As it melts, it'll flow over to it. So I will proceed and show you a way of doing that, okay? Apply the solder here, and now as I apply the solder, okay, cut. Okay, what I have here is the circuit board from the tachometer sending unit. I have some electronic solder, and I have a fine electronic soldering iron here with a very fine point. What I'm going to do is I'm going to apply solder to each one of these connections. I'm going to resolder that. Now what you do to solder is you apply the heat source to the opposite side of the little volcano, and then you apply the solder. And what it will do is it will then reflow, form a little volcano again, and this time it'll be a little bit bigger with a little more mass, and it'll be less likely to vibrate loose to a cold solder joint. So what I'm going to do is I'm going to just sweep across this board, and I'm going to redo every single joint just to be safe.
So now we've soldered it. Now I'm not going to bother putting silicone back on this thing because someday I may need to resolder it again. I don't know. I've put quite a bit of extra solder on there, so it should hold. Now all we want to do, actually you can also see that I JB welded, which is a kind of an epoxy, the lid back on this thing. And if you want, I can show you what that JB weld looks like. Just a moment. I love this JB weld stuff. It's a kind of an epoxy. You mix it up, you know, half and half, and it's a really, really good hard epoxy that I use to mend all kinds of things. But that's what I've done to the lid of this thing. I've just JB welded it all back together, and you notice that I had marked it, and so I matched the marks up, and then I took a blade and scraped the inside smooth, as smooth as I could get it with just a pocket knife. And then I'm just going, these tangs, I just broke them off so that I could put this thing back in here. There were some tabs you can see right there, and there, and there. There were 3 of them that held this inside this cap, and that's why we had to saw it off to take it out backwards. But in case I ever want to disassemble this thing again, I'm just going to leave those tangs or those tabs off. So I broke them off, and because they're broken off, the actual circuit just fits right back in there. And all we're going to do is plug it back in just like this. The only reason we had this on there was just to keep the dust and dirt out of it. Of course, that's the place where all the threads are, so it screws back down on there. So now we've repaired it. We'll just put it back in the car.